Okay, so active object is basically one of the concurrency patterns, design pattern related to concurrency, and it basically is a very important design pattern from the perspective of concurrency, or from the perspective of giving the responsibility to other components, or giving responsibility to other classes, because your then your software design becomes responsibility oriented design. Okay, so typically in a object, invocation of a method is practically same as execution of that particular method. Okay, for example, take this vanilla class. This my class has two methods, do something and do something else. So these two methods, when a parent class invokes this method, at immediately the same time this method is executed. So method invocation is practically same as method method execution. Okay, so method invocation and method execution, they are equal. But in this design pattern, it aims to decouple these two things. Now, what do you mean by decoupling this thing? Suppose that uh, your parent class wants to execute a particular method from this class. Then, what it can do, it will basically create the object of this class, and then start and then call the method from this particular class using that object, and after that the execution will start. Now suppose that it is asynchronous model, programming model, and you do not want the result immediately. What you want, uh, you just want to give the responsibility to the other class, rather than waiting for the result. Okay, you of course want the result, but you do not want it immediately. You are expecting it after some time, and then you want to be free to do other tasks. Okay, so in this particular scenario, this active object becomes very important. Okay, and also it becomes important when uh, the these methods internally needs to be synchronized. For example, if these two methods do something and do something else, they are executed by separate objects, separate threads at the same point of time, then the end result is going to be inconsistent, because they both are trying to access the common data in this particular object. And suppose there is a requirement that these two methods should be synchronized, then in that case it becomes important to have it as a active object. Okay, now to have the active object implementation of this particular class, what we need is, in this class we need to have a queue. Okay, a queue of runnable objects, queue of runnables. Okay, now what is a runnable object? A runnable object is basically the object that can be executed from the thread. Okay, it basically implements the runnable interface. Whatever class implements the runnable interface becomes a runnable class. And we have a queue here, dispatch queue, which is nothing but a list of no, a queue of a blocking queue of such runnable objects. Okay, and when the method is invoked, what we do is we simply put we simply put a, an object, a runnable object for that particular method in the queue, and it is taken by a separate thread for execution. So the task of putting an object in the queue is basically, it returns immediately. It doesn't have to wait for the complete execution of method. It just has to enqueue that particular object. Okay. and the thread that executes this method needs to basically dequeue this particular object. Dequeue the object and then execute. So this way the method invocation and method execution has become separate. Okay, now let us see here the implementation. This class has two methods. One of the method is do something, and what it does, it simply enqueues the runnable object in this particular queue. And what does the implementation of runnable look like? It is exactly same as that method, that is val equal to 1.0. And but this method is not executed at this point of time. The control returns immediately to the main thread, and since this object has been put in the queue, it has to be taken up by some separate thread for execution, and that thread is maintained by this particular object itself. So that is why this kind of pattern is called active object, because traditionally the object runs in the thread context of the parent thread, whereas active object, the methods are executed in the context of the its own thread itself. So the thread is maintained by the object itself. For example, here in this case, when this constructor is called, it basically creates this thread and it starts the infinite loop. Infinite loop takes the object from the queue and it runs whatever runnable is over there. Okay, so for method 1 the runnable is corresponding to method 1, for method 2 the runnable is corresponding to method 2. So in this way the thread which is maintained by this object is actually doing the method execution, whereas the method invocation is being done by the parent thread. And with this kind of approach we are segregating the method invocation from the method execution part. This becomes practically very handy when you are going to implement something like reporting. So in case of reporting, suppose that your parent thread wants to start the reporting function. Let's say you have the raw data of employee attendance system. So you have the raw data for the entire year, and you want to generate the report for the monthly statistics on the number of absentees, and similarly the absentees on the yearly basis. So these two reports you want to generate. So from the UI, user clicks on generate the monthly report. Now user is not expecting that report to come immediately. So what we do is from the parent class we do the invocation to generate the monthly report. So the method in the active object is called, and that basically puts a command in the queue to generate the report, and that command is taken up by this scheduler, and this scheduler basically generates the report and puts it somewhere. And after running that, after the method has been executed successfully, it has to do some kind of callback. Okay, so this example is not complete. In the complete example, in the method call itself, you have to put some kind of handle to return the result. So when the execution is over, at the end of it, the handle will return the result to the parent thread, and in that result the parent thread can send the email to the user. Okay, so this way the responsibility of generating the report has devolved from the UI thread, the main thread, to this particular active thread. And likewise there are several examples that we can think of. It comes in very handy when designing the applications. Typically there are some key portions to this object. One of the key portion is we have to provide an interface so that the parent thread, the parent class can invoke the method. So that interface is required, or that proxy is required. After that, in the method, in the active object itself, we need to have a queue or list kind of thing, wherein we are putting the list of all the commands which are to be executed, and then we need to have a scheduler that takes up the commands on based on certain scheduling algorithm and starts executing them. And finally, after the execution is over, that result has to be pushed back to the parent thread. For that there is a callback function or some kind of variable mechanism needs to be there in place to basically return the result. So using this example, using this design pattern, we successfully segregate the execution of method from the method invocation.